So now that we've identified all the parts of the PQRST complex and where repolarization and depolarization is occurring, let's now talk about how each part should measure and what each part should look like, because this will help us analyze a rhythm. First, let's look at the P wave. So P wave should always be present in a rhythm if it's normal, and there should be one P wave in front of one QRS complex. And they should be up like this, they should be round, they shouldn't be flat. And their measurement should be less than 0.12 seconds, so no more than 3 squares. So whenever you're looking at the P wave, look at those squares that it's taking up and count them, because remember, each small square represents 0.04 seconds. Next, look at the PR interval. The PR interval, again, starts at the beginning of the P wave and extends to the beginning of the QRS complex. And you're looking at its measurement. It should be about 0.12 to 0.20 seconds, so about 3 to 5 boxes. Any more than that, you may be thinking heart block. Here we have a picture of a first-degree heart block, and notice that that PR interval is more than 0.20. Next, look at the QRS complex. It should be behind every P wave, and it should look like this. It shouldn't be very wide or narrow. Here we have VTAC. Notice how wide that QRS complex is. Whenever you measure it, it should be no more than 0.12 seconds, and you want to start measuring at the Q wave to the end of the S wave. Then there's the ST segment. This starts at the end of the S wave and stops at the start of the T wave. It should be flat, shouldn't be elevated or depressed. And if it is, it should be no more than 1 millimeter. And here is an example of an abnormal ST segment. Here we have ST elevation. Here we have ST depression. Followed by this is the T wave, and the T wave should come after the QRS complex and should be round and in the upright position in most leads. And lastly, the QT interval. With this, you're looking at the measurement. Typically, it's anywhere between 0.35 to 0.44 seconds, and men have shorter intervals than women, and it really varies depending on if it's a fast heart rate or a slow heart rate. Fast heart rates have shortened QT intervals, and a prolonged one could increase the risk of ventricular dysrhythmias, like torsades de plainte. Now let's apply this information we have learned about this PQRST complex and analyze a rhythm. So to do this, you want to use an EKG strip that's at least 6 seconds long. And how you know if you have a 6-second strip is you're going to count those large squares and count 30 squares. 30 squares equals 6 seconds. And we're going to go through a checkoff of questions that we're going to answer. And based on the answers we get, we're going to take that information and apply it to what kind of rhythm we're dealing with. So the first thing you want to look at are the P waves. And we're thinking of the 3 R's. We're thinking of regularity of those P waves, the rate, and the resemblance. First, regularity. Ask yourself, are the P waves occurring at the same regularity as the consecutive P waves on that EKG strip? And the P waves represent atrial. So with your calipers, you can start at the first P wave, spread it out to the second P wave, and just go from P wave to P wave and make sure that they're all lining up the same distance. If you don't have calipers, you could use some paper. Then look at the rate of those P waves. Count the P waves within that 6-second strip. Then multiply by 10, and this is the atrial rate. The atrial rate should be around 60 to 100 beats per minute for normal sinus rhythm. Then the resemblance. How do they look? Do they resemble a P wave? How a P wave should look? Because there should be only one P wave in front of every QRS complex. So is that happening? Are all the P waves identical in how they're round, pointing up? And are they less than 0.12 seconds, less than 3 squares? So look at the P wave and count those squares underneath. Then apply the 3 R's to the QRS complex. Look at the regularity of the QRS complex. Are the QRS complexes occurring at the same regularity as the consecutive QRS complexes within that strip? This represents ventricular. You can do this by taking your calipers, just how you did with the P waves, and going from R wave to R wave. Both the atrial and ventricular rhythm, the regularity, should be regular in order for it to be normal sinus rhythm, and that shows that it's originating in the SA node. Then look at the rate of that QRS complex within that 6-second strip and count those complexes and multiply by 10. This is the ventricular rate. And the atrial rate and the ventricular rate should be the same, around 60 to 100 beats per minute for normal sinus rhythm. And lastly, resistance resemblance. How do they look? Do they look like QRS complexes? Is there one present after each P wave? They don't measure any more than 0.12 seconds, so less than 3 boxes. Then look at your T wave. It should come after the QRS complex, be round in the upright position in most leads, and then find the extras within the PQRST complex, those intervals and segments. So look at the PR interval, measure it. Again, it starts at the beginning of the P wave and extends to the beginning of the QRS complex. It should be 0.12 to 0.20 seconds, and the measurement should be uniform throughout that strip. Then look at the ST segment. It starts at the end of the S wave and stops at the beginning of the T wave. It should be flat, no elevation or depression. And then lastly, look at the QT interval, which starts at the beginning of the QRS complex and ends at the end of the T wave. Confirm that it measures between 0.35 to 0.44 seconds. So now let's analyze this rhythm using those questions that we just went over. So I have a 6-second strip here, and the first thing what we want to look at are those P waves. So we're going to look at the 3 R's of the P waves, the regularity. We're going to start at the first P wave, and we're going to take our calipers. We're going to put 1 point of our calipers on that P wave, and then we're going to stretch the other part out so it touches the next P wave. And then what we're going to do is just go down through the strip and make sure they have the same distance within them. So here we go. Making sure that they line up. And so far, they have the same distance. Okay, they are regular. Next, we're going to look at the rate. So what we're going to do, since we have a 6-second strip, we are going to count the P waves and then multiply by 10, and that's our atrial rate. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 10 is 80, so we have an atrial rate of 80. Now let's look at their resemblance. Do these resemble P waves? And they do. They are round, they are upright, there's only one P wave in front of a QRS complex. And their duration, let's make sure that they're less than 0.12 seconds. So we're just going to take our calipers, measure at the beginning of that P wave, and at the end of the P wave, and it's about 2.5 boxes, so we get 0.10 seconds. And then just to confirm that measurement, just go throughout all the other P waves and just make sure that they all line up with that measurement. Now let's look at the QRS complexes, the 3 R's. So first, regularity. So just like with the P waves, we're going to take one end of our calipers, put it on the R wave of the QRS, and then put it on the other R wave of the QRS, and then just track it down through the strip, making sure that they line up together and that they are regular. And so far, they look regular and they are regular. Next, let's count the rate. So count each QRS complex and then multiply by 10. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 10 is 80. So we have a ventricular rate of 80, just like the atrial rate. And then lastly, the resemblance. Do these resemble QRS complexes? Are they where they're supposed to be? You're supposed to have one QRS complex after each P wave. They do. And they look like QRS complexes, and let's measure them. So what we're going to do is we're going to measure at the beginning of the QRS complex to the end right here with our calipers. And when you measure it out and you count the boxes, you get 2.5 boxes, which is about 0.10. And then just go down through the strip and just measure to just confirm. Then look at the T waves. Make sure there's a T wave present after every QRS complex and that it looks like a T wave. It's where it's supposed to be. It's upright. And then lastly, we want to look at the extras. So let's look at that PR interval. And again, you measure that by going at the beginning of the P wave to the beginning of the QRS complex and measure out the boxes. Here we have about 3.5 boxes, so it's 0.14 seconds. And then you just want to go throughout your strip and you just want to measure that and make sure that all your PR intervals line up to be that same measurement. Then you want to take a look at the QT interval, and again, that was found at the beginning of the QRS complex to the end of the T wave, and you just want to count the boxes from there to there. Here we have about 9 boxes, so that gives us 0.36 seconds. And just track that down all throughout the strip and just confirm you have that throughout. And then lastly, we just want to look at the ST segment and make sure that the ST segment, which again is found at the end of the QRS complex to the beginning of the T wave, just making sure that this area is flat, it's not elevated or depressed more than 1 millimeter, and here that is not. So with all those questions that we just answered, whenever we look at this rhythm, it meets all the criteria for normal sinus rhythm with a rate of 80 beats per minute.